Hi everyone, I'm Srisha. In this project, we'll try to simulate the concurrent rocket launching system, right? So rocket archery and all these things comes under the projectile motion, which follows the parabolic path, and it has its own beautiful mathematical and physical descriptions. Okay, so the inputs are like the only they give the range. Okay, at what distance the target is, and we have to hit it. That's the only input we have. And another requirement is that the user can stop, ask the programs to stop, and the programs should stop that particular launch or all the rocket launches like that. Okay, these are the requirements, and we have to do some research before going into it. All right, because it's a physical, this is all involves physical equations. We have, as I'm showing here, right? So we have to be thorough with acceleration due to gravity, range, minimum velocity, at which the projectile has to travel to hit that distance, and the time taken for that projectile to hit that distance, and how much force it should be projected to reach that velocity, and how much fuel is needed. Fuel. All these things will also be dependent on like density of the fuels and etc, right, as I'm showing here. So with all these things in the background, let's dive into the design part of the program. Okay. Yeah, it's fine, no need to worry, we'll go into the everything in deep. um yeah, so this is the design. Okay, I have came up with, right? So here I'm using Java Spring Boot. Okay. Java Spring Boot for all the programming purpose and everything, right? So this is a programming flow. What I have done is I have created one RESTful API which accepts the list of maps. Okay, in the map we have key value pair, right? So key will be the target's names like target 1 2 3, and value will be its distance like 1200 meters or something like that. So all these things will be accepted, and then it will go to the service layer where business logic has been implemented. So here I have created one separate thread called a stopping thread, right? So that will accept, that will all the thread will run throughout the program, and this stopping thread will accept the input from the user and act according to it. Okay. And in other case, since we are using multi-threading, right, we can go for the thread pool or the manual creation of the threads. So I'll demonstrate both the use cases. Okay. If you are using going for manual thread, then we have to chunk it, the inputs into many chunks, and give each thread its part and execute it and ask to execute it. And in that process we have to keep a track that which thread is processing which chunk. So these things has to also be taken care of. So after this, each thread will go and to a function block, and that function block will take um, the prerequisite parameters like mass of the rocket and many of those things. Okay, and it will compute me the minimum velocity, time of flight, thrust required, and how much fuel is needed. Okay, so the prerequisite is the density of the fuel, mass of the rocket, and all those things. Okay, we will get to know when we go into the code. Okay, so all these things will be computed and it will be given back to me. Okay, and all these things I'll just log it into a record. Okay, these are all the findings. These are very required for our response. Okay, these things will be done. And after this one, since we are using only pure software, it will go into a function called launching function, where the whole program, I mean the thread waits, that particular thread waits for the time of flight. Okay, if it will wait for that particular time of flight. Say user in that meantime itself interrupted that particular thread, asking that particular target to stop, then that particular thread is interrupted, and that will be considered as terminated, and the target has not hit. Okay, say if the user has not disturbed that thread, it will he's just let go of it, then it will wait for that time of flight, and then considers as the launching successful. And all these things will be recorded in one log file, that too a synchronous log file, because each thread has to access that resources each at a time, right? And at the end of the program, I'll just summarize everything and put it into a one output folder. Okay, these are all the consideration which we are doing. Okay, the inputs are only okay here, right? So inputs are the only how many targets are given and its distance, and we have to compute all these things. Okay, that will be taken care by this computation function. Okay, and rest all things are we have been designed all these things. So yeah, before running this one, I had run the code in a single threaded environment. Okay, and this is a screenshot, and it took nearly 6 minutes. 6 minutes. Okay, since now we are using this multi-threading, right? It should take less time. Yeah, so there are three cases. One, user did not interrupt any thread, so it should continue. And the user interrupted only one target, then apart from the target all others should continue. And he interrupted all the target, meaning stop all, so then everything should stop. So these are all the function requirements. Okay, so for now we'll just go for one corner case, like stopping one particular thread or one particular target, right? So that will go on. We are just launch the application, right? Yeah, Tomcat server started. So what I'll do is, like, I'll hit this one. Oh, these are all the targets. Okay, 1 to 10. We'll just hit this one, right? Hit. And yeah, it came here. So if you want to stop this one, just say stop target 4 something. So as soon as I press this hit this one, I'm getting attempt to stop target, and rest all are launching. Target 2 is ready to launch, 3 is ready to launch. Excuse me. Attempt to only 4 is attempting to stop. So let's see if it has not launched there. Then apart from target 4, rest all should hit. Okay, so it is waiting for some time, say waiting for the time of flight. So as soon as it each thread calculates the time of flight and everything for each target in that particular chunk. So for each thread will chop for stop or sleep for that particular milliseconds, I mean for that particular time. And then the output is being printed. So that's how it works. See, target for 6 is hit, target 7 is hit, 8 is hit. Yeah, all these things happens. It should take less time. Okay, maybe less than 2 minutes it will take. Yeah, so all targets are hit or done processed, and log file have been saved. So what I have done is I have written a log file in this particular path. Okay, we'll go to this particular path, we'll refresh it. Yeah, here it is. So 35, this is the log file which we have done. Okay, if I can open see target 4, it should have been stopped. User stopped the rocket for target 4. So this particular target has been stopped, and rest all others have been hit. See, we have a target 10 is ready to launch, and fuel loaded for target. This is I believe target 1. Okay, for this particular meter, and this is the maximum height, and this is the duration, and this is the liter of fuel it is needed. Okay, so these are all the findings our program has done. Okay, and these findings have took only 1 minute 25 seconds. That's it. So this is how this program works. So yeah, now let's dive back into the code. Okay, yeah. So what happens is, as I told, there are two methods. Okay, one is using Threadpool and another using this manual thread creation. Okay, some of the prerequisite I'm taking from the properties file. These are the taking from properties file, and yeah. So here I'm executing executor services taking a new fixed thread pool of number of threads. So here I'm taking, like, if there are 10 inputs, 5 will be the threads. If there are 3 inputs, then 3 will be the threads. So that I'm taking number of threads as, and then I'm iterating throughout the input, like 10 means 10 iterations and everything. And here I'm just submitting executors or submit method. This will create the thread, right? So if I go inside say submit, it will accept the runnable, and here is the run method of the thread. So this will each thread will be created. yeah, each thread will be created like this, right? Each will be created, and this is the custom method which I have written here. Okay, here this is the entry point which will take it is okay. I'll come to this one later. So here it will calculate all the minimum velocities, time of thrust and everything, and it will just return me and everything. And here the calculate fuel also, it will just return and everything, and it will write everything to the logs, which is actually synchronized function. Okay, then yeah, it will. Huh. In the meantime, I have also created one stopping thread, okay, which I had told earlier. So this thread will accept the input from the user, okay, and it will accept the user input. And if the user presses stop all, then executor dot shut down. So this will stop all the threads and execution. Or if the user press stop target one, target two, or something like that, then there is something called as future, okay. Future, you can see here, okay. Future, what it does is it will wait for its completion and retrieve the results of the computation. So here when I say the future, okay, okay, when I'm doing here now, I have created one more variable called rocket future, and adding all the submitted values to the this rocket future variable, so that I'll have a track of this variable holds the track of which thread is processing which chunk, like that. So here in this stopping thread, I'm just using this future thread to get to match if the user input exists or matches in the ongoing thread pool executor threads. So if it matches, then I'm calling a method called future.cancel. This will send an interrupted signal. This will send an interrupted signal, and if the interrupted signal there, mm, launch rocket. So here if the thread is interrupted, then rocket launch and target is interrupted, and user stop the function, so that it will send an interrupted exception as a signal, and I'm catching that interrupted signal and then stopping that thread and writing the message to the logs. So this is how it continues throughout the program. And after the end of the program, right, um yeah, it will write everything to the log file. And after that one, I'm calling this write to text method, write to text file. So here I'm just summoning everything and writing into a text file, that log file which I showed you. So this is how this works. Say in another case I told na, what if I don't want to use this threadpool executor for learning purpose? If I you have to create some manual threads. So the only difference is that, like, we can create a threads and hold it in a variable, okay, in the threads list of threads, even because list thread is a class, right? So this is a class which implements runnable. So list means it should have a class. So it can hold a thread class. So here I'm holding all threads variable, and in the, yeah, I create the thread variables. And I told here, right, we have to process the chunk here manually if we are doing all these things, which if you are not using threadpool executor. So if I go to create submaps function, so here what it happens is these are the targets, okay. Each target in the for loop, right, in the for loop, um not in the for loop, okay. It will take that input and it will chunk it, okay. This is a process of chunking. What happens here is, I'll define a chunking size, okay. Say for example, okay, I have this is a better example. Okay, say the input is map size is 5, okay, and parts are 2. I'll say each should have parts 2, and chunk size will be 3, because 5 divided by 2 is 2.5, and I'll round it to as 3, right? So here I'm using two for loops, okay, one for loop and two for loop. Okay, what happens here is the outer for loop, it runs from 0 to the end of the thread, okay, and the inner for loop runs only to the chunking size, like 0, 1, 2, so 3. So in the first chunking method, only key value 1, 2, 3 will happen. So in the next iteration, what happens, the outer for loops run from 3, and the inner for loop starts from 3, and outer for loops run from 3 to the end of the list, and inner for loop runs from 3 to the next chunking size, which is 4, and 0 to 4, it is the end of the list. So the next chunk will have only two values, like that. So 5 elements, iteration 1 will have 3, and iteration 2 will have 2 chunks. So this is what happens, and we will get those chunked response in the sub target, right? It will be in the sub target. So what happens here is, in the sub targets, I'll just iterate everything, and I'll just start the. I mean, I'll just initiate the thread as I told na, compute and launch method. So this is how we initiate a, thread like this, through this is a functional interface, and this will use arrow function, and it will go right. So these are all functions will remain the same. Nothing to worry about. So only difference is that we are not catching any exceptions here. We are not catching any exceptions here, but all other computations will remain the same. Okay. And yeah, after that one, I'll just put everything, and I'll just iterate through the loop and start each and every thread. I'll start each and every thread, that's it. And in the meantime, the stopping thread which I told na, this will check for the user input as above. So if it matches the if the user input matches the thread which is in process, then thread dot interrupt. So this method will call and interrupt a thread. And since that is been interrupted, and we consider it as change of plans and stop it. So this is how it goes on. So yeah, this is how it goes on. Rest all are like a simple thread. And what happens here is, I have created one more function, because yeah, this thread will interrupt, correct, right? So this will interrupt, this will send an interrupted exception signal. So there has to be some function which will catch that one. So I have created this method called handle thread interruption. So if thread dot current thread, whichever the thread it has been interrupted, it is true, then I'll just write those particular messages to the logs here. Okay. And this method will be called while I'm launching the functions. So here, while launching the function, so here I will call it, that's all. So as I told now, launch rocket means nothing but the waiting. So that particular time which we are the time of flight, so that will, this particular thread will wait for that particular time of flight. So this will, as this takes in millisecond, I'm just converting it to the milliseconds and printing it out. So this will wait the thread. So this will be the time of flight. Okay. So if it wait for the time of flight, then the launch is successful. If it has interrupted, then there's a change of plans. So that's what it happens like this. And rest are like basic Java functions, like a write to file and everything. So yeah, this is how continues. So all these things are same for both thread pool and manual thread creation. Only difference is that we are creating it is manually and defining this function. But these things will be taken care by threadpool executor automatically through internal Java. That's the only difference. And yeah, here we are calling that if this has been interrupted or not, like this. Yeah, this is how it works. And yeah, thank you. And yeah, somewhere in our program we may have to use this locking and notify as well as given here, but we are not using here. But we can. There are some cases which we have to use that as well. So this is how it works. And thank you everyone. Thanks.